Hello and welcome to SCREEN.TIME 2020. We have, during the next hour, technical director presentations for you. My name is Volker Helzle. I run the technical directing course at Filmakademie and the research lab. So the technical director course at Filmakademie is a 30-month postgraduate course, and applicants usually come from the field of computer science, computer graphics, math, or in general science. They come from all countries of the world. We have students from Brazil, from Israel, from Egypt. So if you're interested in the course, do not hesitate to contact us. So today, for the first half hour, we have 3 TDs presenting their 4th year work, Janik Otterbach, Ramon Schauer, and Enzio Probst. Followed by that, we will have a tech talk from the final year project, Evangeline, by Caroline Kiesslinger and Daniel Schmucker. So without further ado, let's get started with Janik Otterbach.
Hello, my name is Janik Otterbach and I'm a technical directing student at the Filmakademie. My areas of interest are render technologies, software development, and pipelining for visual effects and animation productions. I joined the TD program 2018, and before that I graduated at the Hochschule der Medien and worked at Unexpected as a 3D generalist. In my first semester, I was working on a trailer for an IP which we developed in a team and is called Wild West Compressed. In the following 3 semesters, I worked on the projects Leading Lights, my research project, and the project The Most Boring Granny in the Whole World. And I would like to tell you more about my tasks in these last 3 projects in this presentation. Let's start with Leading Lights, where I was involved as a shading and pipeline TD. Leading Light is an animation short which serves as a pilot for a series concept. And in this series, light and shadow are at war, and in the pilot, the main characters, Eshy and Aaron, meet. So the probably most interesting thing from a technical point of view is that we were trying to implement Unity into a traditional animation workflow. And we wanted to see how we can benefit from a real-time engine. So we got all the data, like cameras, geometry, animation, and textures from DCC applications, like Maya and Substance Painter, and took them in Unity, where we did the set dressing and lighting. We rendered out multiple outputs to do our final compositing in Uke. Let's jump right into Unity to give you an insight of how it looks like working in Unity. We have a scene for a whole sequence where we can scrub through the timeline to see all the shots in context, and we get already a pretty good preview of the final image. Of course, we can do the set dressing and lighting. Unity is a game engine and not necessarily designed for movie productions, so it is good to have some additional pipeline tools at hand. We were using Alembic for our animation, and in this demo I'm setting up shots with Alembics and using our custom material mapper to transfer information like material assignments from reference assets onto these caches. To speed up the workflow of setting up shots, we created our created a shot wizard where we can browse through the shots and import them already set up. So game engines are fast, but they're not necessarily good at realistic lighting. So to get around some of these limitations, we're going for a more stylized look. I created a tool which turns normal lights into stylized, and I did that using the custom passes in the high definition render pipeline, which are injection points for custom behavior into the render pipeline. In this demo here, we have the stylized, which we can move around and place in the scene. We have the normal parameters we can adjust, and we have additional parameters for the stylized component and for the rim light component. So we wanted to render out multiple outputs from Unity to be quite flexible in compositing. And that's the point where we struggled the most at the beginning, rendering multiple outputs. But luckily we got some support from the Unity developer team, and with our additional render track component where we can specify settings for multiple outputs and additionally pre-render actions, we're capable to render the images demonstrated on the left-hand side. And what we did with these passes and outputs is illustrated in this demo, where I'm comparing the Unity Beauty render with our final compositing. I have to admit that we cheated a little bit. We rendered additional ambient occlusion and Arnold's to get better occlusion and nicer contact shadows. Let's get to the next project, the most boring granny in the whole world, where I was responsible for the pipeline. It's also an animation short, and it's about the relationship between a child and a grandmother and their understanding of death. I created the pipeline, and I took this opportunity to work with USD. So let me just quickly recap what USD is. USD stands for Universal Scene Description, and is an open source project by Pixar. It also includes a file format which is used to describe scenes. Scenes are hierarchies of objects, and these objects are called prims in USD. Now I want to give you an insight of how I've implemented USD into this pipeline. So for every shot in this production, we have one file which is called shot USD. And this file describes the whole hierarchy and scene of a single shot. Let's have a look how this file looks like. We have an XML-like structure, but right now we cannot see any hierarchy. What we're seeing are that we're sublayering different files, and one file for layout, one file for animation, and one file for lighting. And that's probably the strength of USD. We can layer different hierarchies. So basically we have the hierarchy of layout, where we layer on top the hierarchy of animation, on top the hierarchy of lighting. And if we open up the shot USD file, we get a composed hierarchy from the individual departments. So layout is finally creating some hierarchy. We have our top world brim with an environment brim, and we're bringing in some assets like sofa, shelf, and sofa table. And the actual description lives in another file on disk and are brought in as references. Additionally, we're transforming the assets and placing them in the scene. Animation is doing something similar. We have a world brim, a character brim, and the brims for our characters, Greta and Granny. The deformed geometry is also somewhere else, but we're bringing them in with a reference into a geobrim. And now finally to the lighting file. Of course, we're defining lights with their settings. And now if we open up the shot USD file in Houdini, we will see a composed hierarchy from all the departments, which includes our animation, our assets from layouts, and if we switch to the render delegate, also our lighting. Alright, let's get to the last project, which is my research project. And it has something to do with Hydra. Let me quickly tell you something about Hydra. Hydra is a framework which is included in the same open source project as USD. Basically, it's a contract between DCC applications like Maya, Houdini, and Katana, and renderer like Arnold, RenderMan, Redshift. And if both parties follow along this contract, they're capable of being used together. So a DCC application has to implement a scene delegate, and a renderer has to implement a render delegate. If both do that, they can be used together. So if I create one render delegate for a renderer, I can use this renderer with any DCC application which also has the scene delegates. So my idea was to create a render delegate for Cycles. Cycles is an open source path tracer which is also included in Blender. And with having a render delegate, Cycles could also be used in applications like Houdini and Maya. And this idea is actually so cool, and I'm convinced about that someone else had the same idea. And there is another implementation out there which is a little bit further than mine, but I'm still very happy to present you today the current state of my implementation. So we're opening up the kitchen scene in USD View, and we're switching to the Cycles render delegate, and we're seeing pictures rendered from Cycles. We have basic geometry with some basic materials, and we can also see an environment and a sunlight. That's it. Thanks for your attention, and I'm happy to hand over to Raman.
Hello everyone, my name is Ramon. I'm also a TD in the 4th year, and I'm focusing mostly on the creation of realistic characters and also real-time technologies for filmmaking. So most of what I will be talking about is about my diploma project NeoShin. NeoShin is a mostly CG animated music video which is set in the cyberpunk cosmos. And for this we created a main character which is a digital double. So we scanned this person here, Delia. And for this, first of all, I want to show you a little making of or behind the scenes to see how we approach this. So as you can see, we put in quite some effort to get good results from the scanning session, and we not only did scanning for the face, but we also scanned a lot of face shapes in order to construct a rig later. So here you can see the final cleaned up scan for the face in its neutral pose. And here's a little overview of some of the face shapes we scanned. We did a total of 65 face scans, and we are using these to construct our FAX-based rig from this. We also spent quite some time to capture reference material. We did a lot of light turnarounds. We measured the distance between each light and the cameras, and we also took HDRIs of the scanning stage in order to not only recreate the character, but also recreate the environment to have an exact match of the reference and our CG character. In the right image, you can see one of our tests. The screen right side is our CG render. The screen left side is our reference image. And we are trying to get as close as possible. It's still work in progress, but it is coming along. Here's a further version of the shading in different lighting conditions. And then we have a little example of a work in progress of the face rig. It's almost entirely blend shape based. We still need some work in order to blend the shapes together, but we all have all the basic shapes in, and now we are in the stage of refining everything. And then we are using this rig in combination with face capturing. We had a mocap shoot before where we also captured the face, and we are using a tool called Dynamics YZ in order to transfer the facial acting onto our rig. And this is still a very early version, so we have to put in a lot more work, but it's already looking quite promising, and we'll get deeper into that. And here is a little example of what a shot could look like in motion. It's also a work in progress, so ignore all the jittering, but this is what we are aiming for, roughly. Then the second topic I want to talk about is LED wall production. The one part which is not done in CG but shot in real life is the band performance. And the band members will be wearing these reflective masks with an LED screen beneath, which can show motion graphics when they're performing. And instead of going the route of having a green screen, we actually want to put them into our locations. We have this virtual nightclub, which a big part of the scene takes place. And it also has those motion graphics, which will be synced to the music. So the idea is to film the band performance in front of a LED screen, which will have a tracked camera, in order to save some time in the compositing stage and get nice looking images straight away. So we did some testing together with the R&D of Filmakademie and took a look at some of the LED walls. Here's a test we did a couple of weeks ago with the masks, and as you can see, we get some nice reflections on the side. We have the light wrap around the shoulders, and all those are things which normally wouldn't have to be done in comp, and we can get around that. This is the stage we're hopefully shooting on. Originally, we already planned to be done with it, but since Corona came, we had to replan, so we are aiming to shoot next month. And so far, it's looking quite promising. We still have to figure out some problems of the tracking, which we are doing together with the R&D of Filmakademie. Right now, the plan is to use NCAM for tracking, but as a backup, since we maybe also want to use haze or a little bit of fog, we also have OptiTrack, so we are still evaluating which of the two systems would be the better fit for it. And since we need to have our scene in Unreal for our LED wall shoot, we decided to use Unreal as part of our pipeline in general. So we are doing all of our layout of the scenes in Unreal, and then I built a tool which saves out all the transforms, rotations, and so on from Unreal, and then instantiates the scene in Houdini. We can also swap the meshes through higher-res one. So essentially, the workflow is now that our artists can build the scene in real time, and then we can directly render them from Houdini using the pre-built high-res meshes. And then my last topic is my research project. It also goes in the area of characters. It's based on the movie Gemini Man, the work Veta Digital did for that. They used a system for procedural skin pores, which essentially allows to draw curves on a mesh in order to generate those skins instead of using scan textures and project them back on. And I want to do the same in Houdini as a tool, which could provide an alternative workflow. And it also would provide a good base for further simulations, since the pores can be generated on every frame of the animation. They can be done after the animation is done, which would allow reaction to the smaller deformations. So I just walk you through the progress I have so far. First, we scatter points on the surface, and we have a lot of parameters to control them, the way they are spaced, how big they are, and we are using this as our main pore. Then we are generating small hairs for each pore, and those can be deformed regularly using the normal grooming tools or also the curve inputs. And those hairs are projected back onto the surface and used to calculate the direction for each pore, so each pore knows in which direction to look for the next one. And then we are trying to connect them. The idea is that each pore essentially can go to the next pore and then one pore beyond, and it takes into account both the proximity and the direction. And the more it matches the direction, the deeper the pore gets. So if we bring everything together, it looks more or less like this. On the right side, you can see a very close-up shot of what the skin would look like. And on the left side, you can see the results. So the red curves are the inputs. And then you can see the bigger curves are trying to follow those shapes. And then we have those smaller wrinkles in between. Yes, and that's more or less from me. So if you want to see more or connect, you can write me a message, and then I guess Enzio is next. Thank you.
All right. Hi, my name is Enzio Probst. I'm also a TD student at the Animationsinstitut. And yeah, I will tell you about 3 different projects. So I'm amazed by computer graphics since I'm 8. I started it as a hobby when I was 13, and I was always interested in all the technical backgrounds. First, investigating a lot of different ray tracers and the optimizations behind them. And now I'm more focused towards rasterizers, real-time rendering, and game engines. And the first project I want to show you some parts of is a Juggler's Tale, which is a story-based side-scroller with 3D graphics. It is set in a medieval puppet theater, you playing a puppet, basically. And I'm working on it with 3 fellow students since 3 years now. And one of the parts of my work was setting up our IT infrastructure containing workshare, version control systems, issue tracking, documentation, and a backup system. And one specialty of our project is our coloring system. So all our assets don't have textures that directly give them color, but the textures are always only masks. And we then use those masks with a system we built in Engine to be able to color everything during the game and change the whole color palette when walking through the landscapes. This gives us a lot of flexibility for our style. Then one more important thing is our string mechanics. I extended the integrated string physics in Unreal Engine to be able to stick at certain points and also to rip apart. And this becomes an important mechanic during the game. So then one more thing I built for Juggler's Tale is a custom volume shader. We use the Unreal volume for large distance forks. And the problem using it at such large distances is that the detail is not enough for close ranges then, and you get voxel artifacts. So I built a custom ray casting shader to give us more control and also more fine detail for close to camera volumes like those light streaks. You can define custom density cross sections for them and define fall-offs for them and have a lot of control by this. So the next project I want to present is Robo, which is the working title. It's an animated short film which is a combination of hand-drawn humans and CG environments and robot characters. And it is about a couple where his dear wife is dying and the Robo priest is arriving and breaks the whole situation. So for this project I did the pipeline development, first showing it in a graph, what I'm planning to do and how our pipeline should look. It is done in Blender and TV Paint. And the pipeline tools consist of basic saving capabilities, a browser which can load assets and shot files, load in animations from other shots to build upon as a base, loading renders into editorial, and generating UIs for the shading controls that we want to expose. I also did the rigging for the project and the look development. So here you can see one of the shots. It's still an earlier stage of the shot, but you can see how the 2D and 3D components can play together. So this is a screenshot directly out of Blender of one of the shots. And here you can see how our compositing of the 2D and 3D elements is done in camera in 3D space. This allows us to place the 2D planes just as the real characters would be placed in 3D space, which makes it easier for us to match lighting, and also it enables us to have overlaps between the 2D and the 3D characters. Also, we have basically real-time feedback on the final image that we are working on without a render step that takes a long time. Also, I did shader development consisting of different ways of doing cell shading, and I've tried out a lot of different ways of achieving the amount of control we need. And for that I also built little light channel hack, because Eevee does not support light channels or something the like. So I used the R, G and B channels to separate out different lights into groups, and then the actual colors of the lights are only formed in the shaders, so the lights do not have colors themselves. So I also did a number of tests for line rendering, and to render the lines for our 3D environments I tried out the integrated line renderer Freestyle of Blender, which gave us quite nice looking lines and textures for the lines, but we ran into the problem of bad popping artifacts we couldn't get rid of, and it also renders quite slow, and at the time I tested it last, which is now fixed, it wasn't able to render into a separate path, which was bad for compositing and needed more complicated setups. So I tried out some own solutions for line filtering, and they have too much detail to look hand-drawn, so I tried out some detail suppressions using difference of Gaussians with different filter scales, but they make the lines melt together and you lose edge detail and sharp edges. Another one tries to suppress edges that have different directions which are neighbored, but this doesn't allow T-junctions or line crossings, which is also bad. Then I searched for other solutions and found a paper which I am currently implementing in a render engine using Rust and Vulkan. And this render engine should be as flexible as possible, and I'm first integrating it into Blender. So I again made a graph to dissect the paper and understand what I am doing and what the renderer is doing one after another. And then I started implementing one paper that is referenced there as a prototype in Python to test if I got the maths right, and it actually did hold its promises, giving only one local maximum, no matter if it's an edge or a thin line, which other filters can't do. And after the prototype worked, I did the GPU implementation, which is now my current state. You can see here, this is running in Blender. You can see the feature source right now, which is used to generate the features. Then two of the filter stages, which are phase shifted, reacting to different angles. And yeah, this is the other one. And after that, the combined result of the two filter stages, of the two phase-shifted filters, a direction map of the edges. And the same thing displayed as a vector field, where you can see the line strengths as brightnesses and the direction of the vectors as the line directions. And last but not least, the result with non-maximum suppression, so each feature line only has a 1 pixel line, which is then afterwards used to generate the snakes. There's still a fault in there, as horizontal lines still have 2 maxima. I didn't find the error yet, but I will. And yeah, this is the current state, and my next steps to complete this is implementing spatial hashing to manage the feature samples, generate the snakes and different rules for them to break apart and join, and to implement advection for those snakes so they can be tracked over several frames to be temporal coherent. And after that, I need to do the snake parametrization, so I have coordinates following the snake and going across the snakes, and then the actual snake rendering. Thank you for listening, and if you have questions, you can contact me with this email address.
Wow, thank you, Janik, Ramon, and Enzio. These were wonderful presentations. I'm really, really proud of you. Thank you so much. We have time for questions now coming from the diverse live chats, and maybe we start with you, Ramon. So regarding your project NeoShin and your presentation, creating of a digital human, what has been the biggest challenge, and has there been unexpected surprises, and what was the most fun part?
It's not really the most unexpected thing, but the by far most challenging thing is the face animation or the face rigging in combination with the animation, because that's the point where it often breaks and gets into the uncanny. So it's fairly fast to get a realistic result in a still image, but making it move and look still on the same quality is by far the hardest part. And the most fun part was maybe when we had all the scans done and then assembling all the little pieces which we had. That was probably the most fun part to see come together.
All right. Enzio, here's a question for you. What is the difference in working as a technical director, once for game and later then on for film?
It's a good question. Yeah, the big difference is that for games you always have to care about your asset sizes and a lot of performance, and also you have to wrap your head around the whole rasterizing rendering, which is basically totally different from ray tracing, and you need a lot of tricks to get certain effects which you get from ray tracing for free. But also there's a lot of interesting tricks that you can do there which are not basically possible with ray tracers. So it's a really nice field to explore.
Thanks. Janik, maybe a question for you as you're touching this topic of using game engine technology for animated movie production, something that a lot of companies and projects are currently evaluating. So you came to a point where you had the feeling that you needed some offline rendering to achieve what you were looking for. So what's your take on the next years? Do you think you will still need to rely on offline rendering or can do everything in game engine technology?
Well, the possibilities of game engines and their qualities of course growing, and you're getting much better results. There's also this real-time ray tracing now, so I think potentially you could solve our problems we had also within game engine. So you can definitely produce shorts in the same quality, just completely without offline renderers.
But then again, to make this pipeline work, you had to overcome a couple of challenges. So now in the end, you have a feeling of project size and team sizes at Filmakademie. Would you say that using a game engine has been an accelerator to the project, or was it more that you had to overcome so many challenges that maybe in the next project?
I think the biggest gain from this project was what we learned from it. So we took a lot out of this project as we were putting ourselves into new areas. I wouldn't say that we necessarily benefited from real-time rendering, because there were so many challenges to overcome that in the end it would have probably been the same.
Okay.
But yeah, it was fun.
Here's one more question coming from the audience. How hard, easy was it for you to figure out USD, the SDK and API?
How hard it was for me? I think it was alright. I think there's a lot of information becoming more on the internet about USD, and there's also like very good forums where you can get a lot of information, so that has been okay. You get more and more informations now.
Not too tough.
Not too tough anymore.
Okay, we have one more question, which I think I'll answer. I'm curious if a TD student has experience with VFX pipeline before entering the school, or if they have learned it through the TD curriculum. There's different profiles of applicants that we allow to study here. So some of them, yes, they have a previous knowledge in visual effects and animation pipelines, in game technology, but it's not necessarily a required skill. If you apply here, you will run through a theoretical and a practical test, and given on what skills you show us in this test and what you summarize as your thoughts, we decide whether or not you can study with us. So to answer this question, it's not necessarily required. Though you should have very good software engineering skills. You should know your way around in research. These things are really important for the TD course. So with that, I would like to thank the technical director students, because we're going to continue with a tech talk from one of our final year projects, Evangeline, and it will be from Caroline Kiessling and Daniel Schmucker. So Caroline is actually not a TD student, but she has very technical skills and brought these into the project. So that presentation will be pre-canned. We'll roll this to you now. And after that presentation is finished, you have a chance to ask questions, because Caroline and Daniel will be live in the Kaltura chat. So we'll see you after that, and keep your questions coming.
Hey, welcome to our pre-recorded tech talk. We are Daniel and Caroline, and we were the CG lead artists on the short film Evangeline.
We're going to give you a few insights into our pipeline, our tools, and the workflows we use to create the visuals of the film Evangeline.
So the biggest challenge on that film was probably the amount of shots that we had to do. When we started, there were over 120 shots planned, and 109 shots actually ended in the final cut, of which there were 64 shots that would need to have the Louisiana swamp in them. So that was a huge task. And we also knew that we would need to use Maya and Arnold because that is the software that most of the team had used in production before. So we decided to stick with Maya. When you work with Maya, there's always a few problems I find with keeping scenes lightweight, especially when we started the project. That was still back in 2018. And yeah, we knew we would have lots of polygons. Like, look at that tree. We had to do that Spanish moss that is really characteristic for the area there. And that alone would be millions of polygons already. And we would not have only one tree. We would have a lot of trees in there. And so we thought about methods that we could use to keep our scenes lightweight and to limit our data and everything. And then a beautiful thing came along, which was the release of Arnold 5.1. That was in April 2018. And it brought us the procedural node, and it also brought us operators. And basically our whole pipeline was built around these two things. So to make everything perform really well in the scene and also limit our data and everything, we used the pipeline called open source pipeline called SCREEN. It was built and developed by Tim Lehr and Lukas Gotkowski. If you're interested in that, there is another talk on the internet where they talk about that. So basically what we did is we used packed as files for everything. So we would use GPU caches, like our alembics would come into as GPU caches into Maya, and then we would pack them into as files and pack the as files into as files and all that kind of stuff. And the pipeline they built really enabled us to do that in a time efficient manner, like bringing stuff in, updating stuff, and that was really cool. So yeah, this is basically what our scenes would look like. And here we also have a breakdown of one of those shots.
I'm going to tell you a bit about our shading process. Here you can see the turntables of our three characters. I received wonderful textures from Elias Kremer, and using these textures as a base, I added additional detail and normal maps to get enough detail, especially on the shirts, the faces and the hands of the characters, which are seen in many close-ups in the film, as you can see in these shots. And here you can see a diagram of our shading workflows. From our shading task, we would do 2 publishes for any object that will be animated. One publish contains the model, together with simple preview materials that will go into the rig. And the second publish contains the Arnold materials that will be used when lighting and rendering the shots. In order to assign these materials onto the alembic in the lighting scene, we used Arnold operators. I created a small tool that automatically creates these operators in the shading scene, and another tool for connecting all the operators in the lighting scene. This process of loading the materials together with the operators and assigning them looks something like this. And this workflow had a few advantages for us. Any shading changes could be done quickly in the shading file without the need to propagate changes through other departments. And also, by using the Arnold operators, we were able to load the animation using Maya's GPU cache system, which is optimized for good performance with Alembic files. And these operator tools could be run comfortably from a shelf we created for the project. And another tool accessible in the shelf was to adjust the characters' clothes colors or dirt levels. Because the film tells the story over a longer period of time, one requirement was the possibility to switch between variants of clothes or dirt levels. And for that, I built switches into the shading networks, which can be easily adjusted by our Maya shelf using these dropdowns. And here you can see the character turntables with some of these variations.
So not only did we have a lot of assets outside, we also did have a lot of assets inside, because we also had a few indoor sets. And yeah, for that, here you can see a lot of the assets we used in the living room, but they're almost like an equal amount of assets that is used in Evangeline's room. That, yeah, really the amount of assets that we used was enormous. We also had great help building those assets. And I want to drop a few names here, which is Elias Kremer, Niklas Wolf, Harald Dietrichs, Ferdinand Erhard, Verena Nomura, and Paul Golter. They really helped us push through with all the modeling and UVs and texturing, shading. Like Daniel and I, we also did a lot of that, but yeah, they really helped us out.
The project Evangeline has 9 different sequences with different lighting situations, different moods and atmospheres, and that is one of the reasons this project was so much fun for lighting, as it offered such a big variety. From early on, we worked on a couple of key shots to define their atmosphere, and this is the concept art by Toby Trebellia for one of these key shots. As you can see, in the first versions we are still using previous models of the characters, but it still gave us an idea of how the sequence could look like. The shot was revisited every time the characters or the assets were updated, and together with the director Nadine, we continued to work on the look of this scene. And finally, we had the finished assets, the finished characters, and started adding the complete set dressing and other elements like fog. And after many iterations and refinements, we finally ended up with this shot. Of course, we didn't have the time for this many iterations on all of our shots, but for some of the key shots, we tried to really refine the lighting and look as much as we could, since they were the base for the whole sequence. In order to get through the large amount of shots, we created a number of small tools to automate certain tasks. One of the tasks I wanted to make more efficient was setting up matte paintings in Nuke, which we needed for many of the shots that take place in the swamps. This is a Nuke tool that helps with this task. It simply takes the shot camera and a folder containing images. It then scatters the images inside the camera's frustum to create the matte painting. It can be adjusted with a number of parameters, like the tree's height, the distance from the camera, or the number of trees. And by adjusting the random seed parameters, you can change the look of the entire background forest. This way, you can quickly iterate between different versions of the background matte painting, either in Nuke's 3D view or in the scanline rendered 2D view. And there's also a couple of look parameters that can be tweaked to adjust the defocus or the atmospheric haze of the matte painting. And here you can see how this tool was used in one of our production shots. You can quickly flick through a number of different randomly created versions and choose the one you like best without having to place any of the trees by hand.
So as mentioned in the beginning, we had this challenge of the many shots that we have to work on, but we didn't want to lose ourselves in just technicalities and just pipeline stuff. We really wanted to do lighting and comp, and we wanted to make this a really beautiful movie. That's why we built all those tools, that we actually had the time that we could focus on the creative work on the shots. And to finish this talk, we would like to show you 2 breakdowns of the lighting we did.
Welcome back to Screen Time 2020 and Tech Talk for the final year project Evangeline. And now we have the chance to ask questions to Caroline and Daniel, who are live with us. How are you?
Hi everyone, I'm fine.
Hey.
Doing okay?
Sure.
Yes, wonderful.
Are there any?
Congratulations, it looks very,
Thanks.
very beautiful. I really like it. Caroline, can you maybe start, or a question I have, so it was more up to you to become more technical as a typical animation student. But what made you follow that path? Why did you decide to?
Well, I think I had an interest in like more technical things early on because I went to, like right after school, I enrolled in mechanical engineering, and then I decided this is too technical, and then I kind of found like a good in between with 3D. So it's like super creative, but you can also do the technical challenges, which, yeah, I think it's really inspiring to do that. Yeah.
Cool. Maybe a follow-up question on for Daniel. So because it's a question that is directed to a technical director, and I think the person asking might wonder about the structure of the curriculum here. So how creative can you be in your projects, or do you completely concentrate on the technical side? So I think it's a very interesting question.
Yes, especially on this project, I've been doing a little bit of both because I really like to work like in between. I love creating tools, but with the purpose to make my creative work easier or faster. And so on Evangeline, I was able to write scripts for pipeline stuff or create a tool in Nuke and so on. But I also was able to work really creatively together with Caro on the shots, doing the lighting and compositing. So it's both, whatever you like. Yeah.
Yeah. The shot work is the lighting work. That's very creative work. And I think maybe to add on for the chorus, these things are really not set in stone. We're giving the students room to explore his capabilities. So a rigging TD needs to have a fundamental understanding of rigging and animation. So he needs to be creative as well. And I think that applies to pretty much everything that TDs touch. It's not just a technical aspect. You need to have a creative and a somewhat artistic understanding. That's the space we offer during this course. And Daniel, one other question about the tools that you showed by you. Are those available? Do you sell them for big amounts of money? Or?
I am about to put them up open source on GitHub. So I got the code. I'm free to have it and put it online now. And doing minor fixes and code cleanup, because it was a production tool, so it doesn't have the cleanest code right now. But doing a cleanup and then getting it up there on GitHub.
Yeah, sounds good. Here's some comments coming in that congratulate on very impressive work, awesome light work, guys. So I think that's very positive to hear. But I guess not everything was easy in this project. Can you talk about the challenges and the maybe the difficult parts?
Well, I guess the most difficult part was right in the beginning when the director told us that this will be like a 7-minute short, and Daniel and I knew, okay, we're going to be mostly like 2 people for lighting, so that's going to be not too easy. And I guess this was really the biggest challenge. It was super intriguing that we knew we had this amount of shots and the director wouldn't want to compromise, so we had to make it work. And we did make it work. Like in the end, we counted backwards and realized that we had 1.9 days from setting up the shot to final compositing. So our pipeline, like all the tools that we built, were solely for the purpose to make it work and spend our time on the creative part. And I guess that was like a really cool moment when we realized like all the stuff that we built, all the technical stuff really enabled us to do that film like in that quality. So I guess.
Anything you would fundamentally change in the choice of tools and pipelines, or would you say like no, these were all wise decisions, or are you now at a point to say like, oh my God, if I would have only used Maya or for that part, or Houdini for this part,
I would always choose Houdini for everything, I guess. But that's, I don't know. I think the worst part was using mesh in Maya for instancing and scattering stuff, but like at the point we needed to decide, most of the people were used to Maya, and I thought, okay, if I don't know, if my appendix explodes and I'm out for 3 weeks or whatever, then nobody can do the set dressing in Houdini. So we decided
we were pretty pragmatic. We used Maya because like the pipeline Tim and Lucas built was already set up in Maya, so we had a good starting point there, and we went from there. But I think we did use much of a sequence-based workflow for the lighting, and this would have been a lot easier using a tool like Katana. But then again, we would have had to build an entire pipeline around this first, so who knows if it would have worked out better. And in the end, we got it. We got more than 100 shots out of it. So it worked fine.
Yeah, it's good that you mentioned Tim and Lucas. So just for those who don't know them, these are former TD students, so they have a fan. And they built quite sophisticated pipeline tools that, of course, other projects work with at Filmakademie and make use of, so they can be more efficient. Actually, these tools are also published, so not necessarily every tool that a TD or a technical person at Filmakademie creates is published. We have a procedure where we check the source code, and then the students once they graduated, they can take it with them and put it on GitHub. But that's the Scarif pipeline tools. If you Google those, you'll find them, and there's plenty of presentation material from FMX and Tech Talks in the past. So yeah, wonderful. That's really good. So maybe at the end, let me ask about your future plans. You're pretty much graduated, so your graduation presentation will be in a few weeks. Originally, it was planned for March, but then there was this little virus crisis. So that's obviously a challenge for all of us, but maybe also for your future plans. What are you up to? What do you have in mind? What did you have in mind, and what is the reality that you're faced with now?
My plan was to move to Vancouver in May, and that did not happen, obviously. And my current plan is this is basically my lunch break because I'm working at Rise of X at the moment. So
okay.
Yeah.
Yeah, for me, similar. I was about to give my biometrics for work and travel visa to Canada, and then the place shut down. And so, yeah, still don't have the visa. So Canada plans are somewhat on hold, but I'm looking like in Europe now for lighting and compositing 2D. Yeah.
Wow. Okay. Caroline, Daniel, thank you so much. I can tell you, I will already miss you once you're gone, and the wonderful work that you did. That's it for the technical director screen time hour of presentations. And at 3:00 we will do an online premiere screening of the Beauty and Blee show. So stay with us and connect back in a few moments. Thank you. See you.
Thank you. Bye.
Bye.